Welcome to Math Challenge 528. Math Challenge for school exams, junior and senior Olympiads and all competitive examinations. Now here we have a circle. The diameter is 25 units and a cyclic quadrilateral. The cyclic quadrilateral, the four sides, one of the sides of the cyclic quadrilateral is a diameter that is 25 units. One side is 7 units, one side is 20 units, and the fourth side is x, and we have to find the length x. We have to find the length x of the cyclic quadrilateral inside the circle, diameter 25. So length of x of this cyclic quadrilateral, where diameter is 25, Math Challenge 528. Now draw the diagonal as shown. You can see the animation. The animation diagonal, supposing the length is p. The length of the diagonal is supposing p units. So you are drawing the diagonal as shown by the animated line. Now angle in a semicircle is a right angle. So in the right angle triangle, diagonal p will be equal to hypotenuse square minus the other side square, that is 25 square minus 20 square, square root of that is 50. We are drawing the diagonal, and because angle in a semicircle is a right angle, we are getting a right angle triangle where the hypotenuse is 25 and one side is 20. So the other leg would be square root of 25 square minus 20 square, and when 25 square, 625 minus 20 square, 400, that is 225, square root 15. So the length of the diagonal P is 15 units. So this diagonal, you can see the animation, length P equal to 15 units. Now we draw the other diagonal. See the blue dotted line. See the animation, blue dotted line. Now this diagonal, supposing the length is Q. Again, angle in a semicircle is a right angle. So in this right angle triangle, the diagonal Q will be equal to square root of 25 square minus 7 square. 25 square minus 7 square, square root of that. So the diagonal Q will be square root of 25 square minus 7 square, that is 24. So the length Q is equal to 24. P we got 15 and Q is 24. So we got P equal to 15, Q equal to 24. Now we apply Brahmagupta theorem for cyclic quadrilaterals. Brahmagupta theorem or Brahmagupta's rule for cyclic quadrilaterals. Diagonal to diagonal, P into Q is equal to x into 25, product of one pair of opposite sides, plus 7 into 20, the product of other pair of opposite sides. P into Q, that is diagonal P into diagonal Q, equal to the product of opposite sides added. So 25 into x, one pair of opposite sides, 7 into 20, the other pair of opposite sides. That should be equal to the product of the diagonals. So P is 15, Q is 24, the product is 360. And x into 25, that is 25x, and 7 into 20, 140. So 25x will be equal to 220, x will be equal to 220 by 25, which is 8.8. So the length x is equal to 8.8 units. We are applying Brahmagupta's principle, Brahmagupta's theorem or Brahmagupta's relation, Brahmagupta's rule for cyclic quadrilateral. The Brahmagupta formula says diagonal into diagonal, P into Q will be equal to the product of opposite sides added. So x into 25, one pair of opposite sides, 7 into 20, the other pair of opposite sides, and P is 15, Q is 24. So 15 into 24, 360 equal to 25x plus 140. and solving we get x equal to 8.8. So the length x is equal to 8.8 units. That is the application of Brahmagupta's formula for cyclic quadrilaterals.